some problem solving with factoring here. So what we'll do is we'll read through this one, pick out what's important, and see if we can't figure out what this question is asking us. So a rectangular garden has an area expressed as an algebraic expression. Very odd way to express something. Determine the algebraic expression for the length and width of the garden. Okay, so what this is saying is we have some rectangular garden. It's possible a square, but we're not entirely sure. But we do know that the area of this garden is represented by the equation they've given us, which is that 5x squared minus 13x plus 6. Okay, so in other words, let's decompose area. Area for a rectangle is just the width times the length. Okay, so in other words, we need to figure out what this width is and what the length of this object is. Okay, we need two products. Now this is a whole version of something. This is an entire expression. When we factor things, we set them up as two sets of brackets, just like this area. And when to get like that, we got to do some factoring. Okay, so obviously this question is asking to factor this to find out what the width and the length of this object is. So we'll go to a new page here. 5x squared minus 13x plus 6. Okay. We're going to use that fearless factoring method again. That way we can go a little quickly through this. So for fearless factoring, same concept. We have our A and C, so we're just going to write out the factors of these. So 1 and 5 are the only factors of 5. 6 has two sets, 1 and 6, and 2 and 3. We're going to find out the products, and the products need to sum to our B term, which is negative 13. Okay, so we'll do a little trial and error. Very quickly, if I take a look at this, 5 times 6 is going to give me 30 and 1. That one's not going to work. 5 times 1 and 6 times 1 gives us 5 and 6. That's not going to work. So what we figured out is this first column is definitely not the set of factors. So we've narrowed it down. It needs to be this, but we're just going to double check which version of it it is. 1 times 2 and 5 times 3, that gives me 15 and 2. That's definitely something that could work. The only problem is this is a positive value. And for this to work, I'd have to make this 3 negative. And that would be negative 3 times 2 gives us negative 6. So I got to see. It doesn't look like that version is going to work. So that's a little tricky. It's a good thing we noticed that. Let's jump back. And maybe it has to be cross. So 5 times 2 and 1 times 3. That gives us 10 and 3. Ah, that works. I get two positive values. So that's an interesting scenario where we got two different style methods of factoring. The terms that we multiplied together almost gave us the same answer, but we got to pay attention to the operation. So that's great. That's all set up. The last step here is just setting up our brackets. We know that there's technically an x beside each of these because this is x squared. We're going to use these as the first term, so one of them will have x, the other will have 5x. And now the important part, because 5x is multiplied by positive 2, it can't go in this bracket, so I put it in the other one, positive 2. And because 1x is multiplied by 3, they have to go in opposite brackets. So we have positive 3. So there we have it. If we're writing the area of our circle, or sorry, not circle, the area of a rectangle, we know that we'll call this the width. We're not entirely sure which is which, so it doesn't actually matter. But we know that one of the lengths is x plus 2, and the other length is 5x plus 3. Okay, and that gives us our area. That was the expression used above of 5x squared minus 13x plus 6. We can zoom out to get a better view of that. Oh, apparently there we go. Awesome.